For this video, we're going to be looking at the data portion of Lab 2. You will be given data, different lengths, different masses, and different volumes in which you will be converting, so using the same conversions that we looked at in the pre-lab portion. Let's look at the lab data sheets for Lab 2. We're starting with units of length. So the very first one says for you to name the tallest person in the group. Well, since we are not doing groups this semester due to social distancing, you don't need to fill that blank in. So you can go ahead and cross that out if you would like. So the height in inches of the person that I measured was 69.12 inches. So this 69.12 inches, that is what you're going to start each of your conversions with. So you're going to take this measurement in inches, and you're first going to convert it to meters, next to centimeters, then kilometers, and finally feet. So if you looked at the pre-lab video on the previous slide, what you're starting with is this 69.12 inches, and you first need to convert that into meters. So notice this first conversion is going to be English, inches, to meters, metric. So whenever you're going between English and metric, you need to look up a conversion factor. You can't just move the decimal point. So you would find a conversion factor getting you between inches and meters, and then set up your dimensional analysis so that you're canceling out the inches and you're left with meters. Once you have your conversion or your answer in meters, you can then go from meters to centimeters, which is the second one. I recommend doing this because if you'll notice, going between meters and centimeters, this is metric to metric. And when you do metric to metric, you can simply move the decimal point. It's a little bit easier than going between English and metric. So make sure that you are converting that original amount, 69.12 inches, not only to meters, but also to centimeters, kilometers, and then lastly feet. When you put your answers in for each of these 4 different units, make sure that you are using significant figures. So since our original amount, 69.12, let's count the sig figs in that number. So all of the numbers are non-zero, so that means they're all significant. So this gives me a total of 4 significant figures. So since I'm going to be multiplying and dividing, we're looking at the sig figs as a whole. So since I have 4 total sig figs in my original number, that means that I'm going to want 4 significant figures in each of my answers. Next, we're doing length again, but this time, instead of the height of a person, we're using or starting with the height of a 100 milliliter graduated cylinder. So you can see a photograph of a 100 ml grad cylinder to the right there. And what I did was I took a ruler and put it next to the graduated cylinder, measuring it from the base, this red base of the cylinder, all the way to the very top. And I measured it in centimeters. So I used the centimeter side of the ruler. And when I measured it, I got 24.11 centimeters. So we're now going to take that amount and convert it. So how many meters is that? How many inches is that? How many kilometers and how many feet? Okay, so the first one going from centimeters to meters, that's going to be metric to metric. So for that one, you're just going to move the decimal point. So you can use that King Henry died drinking chocolate milk. So the KHD space DCM. So what goes in this empty space here is going to be the letter that's in common. So what I mean by that is we're going from centimeters to meters. So the letter in common's M, meter. So my base here is going to be an M. Now don't get that confused with this M on the far right. This M is millimeter, so that's the milli prefix. Okay, so to do this conversion, you're going to start at the centimeters. That's what our original units are in, and we're going to go to the middle base, meters. So for that, we just need to move our decimal point 2 spaces to the left. Start at the decimal, move it 2 spaces to the left. Now when you're reporting your significant figures, once again, you want to count the sig figs in the original number. Just like the last example, all of them are non-zero numbers, so they all matter. Once again, giving us a total of 4 sig figs. So when we write our answers, we want to make sure that we're including 4 significant figures in the answer itself. Just going to put a 0 here as a placeholder. So all 4 of your answers should have 4 significant figures. Next, we're moving on to mass. So we're going to be using the mass portion of the conversion factors. So the first one is having us take the mass of an evaporating dish. So I have a picture of an evaporating dish shown here. We'll be using that in one of the labs this semester. So I put this evaporating dish on the scale and then measured it in grams. Got 55.066 grams. So now notice this time, counting the significant figures, it looks like I have 5. So when we're using conversion factors, we're either multiplying or dividing. So that's why I'm looking at sig figs as a whole. So since I have 5 sig figs in my original number, all 4 of my answers when I do my conversions over here should have 5 significant figures. So my first conversion will be going from grams to kilograms. My next conversion will be getting that into pounds, then tons, and then lastly decigrams. Okay, so this DG is deci, not deca. So what do I mean by that? Let me show you on that scale that we used for metric. So it's King Henry, I forgot the H, let me erase that. King Henry died, space, drinking chocolate milk. So this DG, deci, is this D right here. So this is the deci D. The D over by the H, put a rectangle around that, that's deca. So if you were to see the units for that, it would be DKG. Whereas this D over here by the centi is just DG. And that's the one we're looking for that last one. Let's look at the next example. So the next example asks you to take the mass of your group in pounds. Now usually we do this experiment when we're doing it in person in groups of 3 or 4. So what you would do is you would estimate the weight or the mass of your entire group. Okay, since we're not having groups, I just picked a number for you to use, and I picked 375 pounds. So you're going to take that 375 pounds and you're going to convert it first to kilograms, then centigrams, then tons, then milligrams. Once again, pay attention to your significant figures because you want to report each of your answers to the correct number of sig figs. The next unit of measurement that we're going to be looking at is volume. So we've done length, we've done mass, and now we're going to be using volume. So for volume, the metric system uses liters or milliliters most often in chemistry. So to do this measurement, what we're doing is, if you can see the picture to the right here, notice there is a beaker of water, and then there is a 10 milliliter graduated cylinder, and I'm holding a dropper here. Okay, so what we're doing is we're sucking up some water from the beaker into the dropper, and then we are dropping that water into the graduated cylinder. The purpose of this is we're trying to see how many drops of water it takes to get to the 1 milliliter mark on the graduated cylinder. So I'm counting the drops as I'm adding them. Once I hit the 1 milliliter mark on the graduated cylinder, I stop adding water. So the very first blank asks, okay, what is the total volume in the graduated cylinder? Well, the goal was to hit 1 milliliter. So I stopped exactly at the 1 milliliter mark. But notice, when I'm measuring with a graduated cylinder, I always want to go one past what the device allows. So I didn't just write 1 and stop there. What I did was I wrote 1.00. I went to the hundredths place in the decimal point. So by doing this, by having a decimal and adding 2 zeros, what I did was I changed the significant figures from just 1 sig fig if I stopped at 1, and now I have 3 significant figures. Because those zeros after the decimal point, those zeros are going to count. Because I started counting at the 1, and since there's a decimal, all zeros after the 1 are going to count. So when I'm doing the conversions off of this 1 milliliters, I want to make sure that all my corresponding conversion answers have 3 sig figs in them. Now the next line says, okay, well, what are the total number of drops? So as I was trying to get to the 1 mil mark in that 10 milliliter graduated cylinder, I counted the drops I was adding, and it took a total of 24 drops to get to 1 milliliter. So that 1 milliliter of water is equal to 24 drops of water. Now this 24 drops, this is an exact number, just like conversion factors are exact numbers. So I am not using this number to count my significant figures. Okay, so I'm not going to take that number into account when I'm trying to figure out the significant figures that I need to report my answer in. Okay, so let's look at the next one. The next one's blank. So since the next one's blank, you can guess that you need to do a calculation to figure out this next one. And it's asking, okay, what is the volume of 1 drop of water? Well, the volume of 24 drops is 1 milliliter, but I want to figure out the volume of just 1 drop. So to do that, I want to take my total volume of water, which is that 1 milliliter, and I want to divide it by the number of drops that I used. Because what that'll do is it'll tell me what the volume is of just 1 drop. So once you have this amount, remember the units on this amount are going to be milliliters. Also remember you should have 3 significant figures when you're reporting your answer in that space. This number here, the volume of 1 drop of water, that's the number that you're going to take and convert now into liters and then into quarts. Next, we're going to be doing some volume conversions based off of the volume of a crucible. So I have a picture of a crucible off to the right, and we'll use the crucible a few times in lab this semester. So what you're going to be using it for in this lab is you're going to estimate how much liquid can fit in that crucible if you filled it to the very top. So for reference, I have a 50 milliliter graduated cylinder in the picture next to the crucible. So you can guess that the volume that can fit inside the crucible is going to be somewhere between 0 and 50 milliliters. So I want you to take a minute right now and just estimate. And don't worry if you're way off, okay? But guess a number between 0 and 50. And what I want you to do is I want you to estimate to the 10th spot. So what do I mean by that? Well, I want you to go out 1 decimal point. So whatever number you pick, so say you pick 10, okay, I want you to write 10.0, making sure that you just go out 1 decimal point. All right, so make sure you have that number because now I'm going to give you how much can actually fit, but I want you to actually guess before you see the true value. So how much can actually fit in that crucible is 30.9 milliliters. So we're going to use these two numbers are estimated and are measured to calculate percent error. So when we calculate percent error, I have the equation written here. We take our true value, and we did this in the pre-lab. You take your true value, subtract it from your estimated, divide it by the true, and then to get it in a percent, you multiply it by 100. So the difficult part is figuring out, okay, which of these two values is the true, which of these two values is the estimated. So in this case, the estimated is, of course, your guess. So you'll plug whatever your guess was into the equation. And then the measured value, that's the true value. That's what actually fits in the crucible. So that's going to go in the true spot. So 30.9 will go here, and it'll also go down here in the denominator. Now remember, when you're using this equation, these bars here are absolute value signs. So if you happen to get a negative number when you subtract your true from your estimated, or I should say your estimated from your true, just change it to a positive. Okay. Also make sure that you're doing the subtraction first. So do the subtraction in parentheses. You need to do the subtraction before you do the division. Otherwise, you're going to get different answers. So once you do the subtraction, then divide by 30.9. Don't forget to multiply by 100 to get it in a percent. Now, when you did the division, what you did was you canceled out your milliliters. So the units on it is just going to be a percent sign. Make sure you're also taking into account significant figures when you are reporting your answer for percent error. And remember, we are doing a subtraction, and the rules for subtraction is looking at decimal places, not significant figures as a whole. Now down here, you see volume in, then you have KL and CL. So what these are is kiloliters and centiliters. You may not have heard of these units before, but it's just metric units. So once again, you're just using that KHD space DCM. And what I want you to start with is the volume of the crucible, the measured, the actual. So you're going to be taking this 30.9 milliliters and you're going to convert that into kiloliters and then into centiliters. So when you're using this metric to metric standpoint here, your base is going to be an L for liters. So milliliters is this M here, centiliters is this C, and then kiloliters is this K here. So you can just move the decimal point however many spaces that this diagram here indicates. And that should complete the lab. So don't forget to submit your answers into the form posted on Blackboard and let me know if you have any questions.